Okay. This doesn't seem right. A little on the, not that many people here at the park.
Jake isn't here. Jake's here. Jake's been stealing plungers rather than. I think we're all sitting in different spots.
I saw it.
I think that's what it is. We mixed it up.
I saw that.
It's all good.
Well,
There are a lot of long weekends where Thompson's not going to be leaving.
right.
A lot of Panthers fans.
Jake's stealing plungers.
I think like 5 Panthers fans.
Alright, well, that's why we make these videos. And follow along here. Alright.
When's the test going to be? Is it going to be this week?
That's actually a good question. Yes, we're going to have some sort of assessment this week on
Team test.
on Wednesday or Thursday. Since we have class today, we'll have class tomorrow.
Harder test.
Sorry?
Harder test?
Team test.
Partner?
Partner.
Partner. Oh.
Carl.
Wait, is that a
No. The details will follow on that, though. I will do.
That's going to be tough.
Yeah, I will tell you this right now, though. Whatever the test is, whatever you see, it's going to involve the trigonometric identities. Make sure you got those down pat. Right? The test may literally just be, give me these identities, give me these identities, give me these identities, give me these identities. Okay? So, yes. So, definitely want to make sure you've got those down. Okay? All right. So, here. So what we're going to be up to today, really, is just making sure we've got down all the sets of identities that we would need to use. Okay, so basically, you've got a. You should all have. These are in the book. By the way, if you want them, and I think I've given you a printout of them, or there's a printout on Canvas that you can get. But if you open your book, this inside flap here, okay, right there, has them all. Every single identity you could need to know, all right? The ones that you'll need to know for me in here are going to be the, basically, the definitions of the 6 trig functions. So, that the SOHCAHTOA, that sort of thing, sine is equal opposite of hypotenuse. Or you could do sine is equal to y, some variation there. All right. I prefer, just to let you know, I prefer the version where sine is equal to y, cosine is equal to x, tangent is equal to y over x, etc. Because those tell you specifically how they work for most of our stuff. So those definitions of the 6 trig functions, you need to know the reciprocal identities. Okay, the quotient ones. Okay, the Pythagorean identities. Okay. Then you want to so these we can group together as basically the fundamental. Okay, because these are all based off of the definition. I can prove every single one of these IDs based off of the definition. Then you've got the 2 for graphing, the cofunction. Okay, and then the even or odd, or sometimes referred to as the parity identities. Okay. Okay, these are your graphic ones. Okay, and then the last group that we're going to look at, or that you need to know for this test, would be the sum and difference. Yeah. Slow way. Shoot. And then the double angle. Okay. So. And these, you can think of these as the algebraic ones. Okay, because those two are all about solving things and using them mainly to an algebraic equation. So you have your fundamental ideas, which is like the basic definitions, reciprocal, quotient, Pythagorean. You got what your ones for graphing, the cofunction, even and odd, and you got some algebraic ones, sum and difference and double angle. Okay, a lot of these we were not going to take a look at this year. For example, the power reducing sum to product and product to sum formulas. Those are the last kind of three on that sheet. We're not going to cover those. Okay, they do occur, but they do so very rarely, and there's things we're not that interested in dealing with. Okay, so we might cover them, but if we do, it'll be after the test this week. So it will not; those three will not be on the test. But if you're studying, the ones you need to know down pat, that is, have basically good to go from memory, are these guys right here. Okay, so it is a lot. There's a lot of information here. Kind of the best way to go about it is to look for patterns again, look for ways to kind of help you shortcut things. The nice thing about all of these right here is you can actually derive them all fairly quickly from just knowing what the basic definition is. Okay. While these over here, not so much. These really only occur with graphing, so you'll kind of keep that in mind.
What's the cofunction? Is that
that's the idea that, like,
pi
yeah,
over 2 phase
exactly.
shift? Oh,
Yep.
perfect.
That the sine and cosine are the same thing. They're just off by a pi over 2
Yeah,
shift.
sick.
Okay. Well, even odd tells about the functions themselves. Sine, tangent, cotangent, cosecant are all odd functions, meaning they follow the definition of what it means to be odd, while cosine and secant are both even functions. Okay, meaning that they have symmetry about the y-axis. Okay. Okay. So, and then these angle ones too. Nice thing is double angle you can get from sum and difference. So really, if you know your sum and difference formulas, you could get the double angle follow for free. So that kind of helps cut things down in size. Okay. Any questions about what to expect later on this week when we have a kind of a test on it?
So you basically just expect this to be able to regurgitate these?
For the most part. I'll give you more details about it tomorrow, specifically, and because, well, first and foremost, would you guys want to have this on Wednesday or Thursday?
Thursday.
Thursday is a better day? Okay, I think in your case, you'll just either take it early on Wednesday or something like that. Okay, so in that case, I'll give you some more details about it tomorrow, and we'll just basically make sure we're good to go for that this Thursday, okay? Which will be good, because we will be moving on to new stuff after the break, okay? So, one thing, so there will be an element of just regurgitating these, okay? But also, too, there'll be elements of actually solving or working out problems involved in these things. So let's go ahead and take a look at how some of that works, okay? Okay, so again, using trig identities. Okay, alright, so basically there are three types of problems that you see when dealing with trig identity problems. We've seen all three of these, but today we're just going to make sure we got the problem solving completely down before we move forward. Can anybody name the first type that we saw? I had a big complex thing and I made it equal to a single thing, which meant I did what?
The first one.
Simplify. Okay. So you generally simplify. That's our first thing we do. Now, the second thing we do with these things
Go for hardest.
would be what?
Hardest side first.
Okay, hardest side first. So that was for, we did those steps when we had to verify
Ah.
that two sides were the same. So verify, and then the third way would be to solve for an angle, or actually to solve, okay? So these are the three types of problems. Simplify means exactly what it means. You've got a large, nasty thing, you're trying to get it down to just one thing only. Verifying, that's the one where we had that large process, which you guys started to name off. But that's where you're trying to make the left-hand side and the right-hand side equal to each other. And then solving would just be, I've got something, and I want to figure out what value of x or theta makes the thing actually work, okay? So it's kind of using actual numbers, okay? But with verifying, in all three cases though, there's kind of a good, like a list of steps you want to follow. So what would be the first step? You're saying it?
Hardest
Okay.
side first.
Use the hardest side, so basically choose the harder side first. Okay. Then what do I do?
Sugar.
Basically any algebra steps, okay? Okay, so, if add things that can be added together, factor things that can be factored, get common denominators, that sort of thing, okay? Then what?
Straight
And actually use the identities, or so you
Just
trig IDs. Okay, and then what's the final step? What happens if nothing works?
Converted all to sine cosine.
Good, the nuclear option. Okay. Okay, good. So this is kind of what we do here. Any questions? All right then, good. So, basically, what I want to make sure we do here is it's all